So how are you celebrating Halloween this year? In the real world or in the metaverse? Well, the mask is a clue to our latest Optica online technology meeting. Let me be controversial. Hey Siri, for how long will we have mobile phones around?
I'm sorry, Jose. I haven't a clue. Ask my friend Alexa.
You see, no one really knows. In my opinion, we will not carry these bricks around forever. Because the future is much lighter devices that show what's around us, around the corner, and even around the real and imaginary walls. But don't throw out your mobile phone just yet. We need major improvements to headset design. They should be lighter, less expensive, and we need to enhance the visual metrics such as field of view, frame rate, and latency. And don't fall for hype.
I believe the metaverse is the next chapter for the internet.
Remember October 2021? When a company that provides social media platforms and data centers changed its name from Facebook to Meta? And suddenly mainstream media was talking about the metaverse, the meta surfaces, the meta optics, and the meta bags.
Our company is now Meta.
What happened since? This was the reality check as explained by Mac Rumors a few months back.
Now, Apple has said to have been unhappy with the productivity of manufacturing partners that are tasked with supplying the two micro OLED displays for the wearer's eyes and the outward-facing curved lenticular lens. Now, the micro OLED displays were reportedly supplied by Sony and TSMC for the prototypes, but it's not known who is supplying them at the larger scale. Now, as a result of production challenges, Apple is preparing to make fewer than 400,000 units in 2024. We do know that the initial launch will be US only, but we also got a little bit more information that Apple is apparently planning the United Kingdom and Canada as two of the first international markets to get the mixed reality headset by the end of 2024, according to Bloomberg's Mark Gurman. And Gurman also said that Apple is looking at bringing the Vision Pro to Europe and Asia soon after, with Apple engineers working to localize the device for France, Germany, Australia, China, Hong Kong, Japan, and Korea.
On October 31st, in just a few hours' time, we will review what is needed next from the optics and photonics community. What are the big challenges ahead and how will the photonics community solve them? Remember, you need to register immediately if you want one of the last places in our Zoom room. Here is the great lineup of expert speakers: Edward Tang, Avegant, Pia Harju, Dispelix, Hanan Shamir, Everysight, Hendrik Zachmann, Jabil Optics, Tomas, Sluka, CREAL. And these corporate members get to show one slide and explain how the breakthrough technology is relevant to AR and VR.
Frank Marsman, Adoptics, Tobias Heus, Hollow Eye.
Niklas Hansson, New Technology. Andrzej Kaczorowski, Sfeven Photonics. Erhan Ercan, More Photonics.
Peter Gussel, Pixeligent.
And our latest Optica member, Maciej Kasowski, from Inside.
That's a frightening list for just a 2-hour session. Let's start now. Thank you very much, all of you, for being here. This is a 2-hour session in which we are talking about AR VR market. I would like to thank all of you, but especially the corporate members of Optica that make our dream come true. Many people keep asking us, what is the corporate membership benefit? The corporate membership benefit is that you want us to do our job. If you want us to do our job, please become members so we can continue enjoying what we are enjoying. We are a team of 184 employees at Optica, a percentage of them dedicated full-time to the industry, and our members have 90% small and medium enterprise less than 250 employees. I would like to remind all of you that here we're speaking on behalf of a very large organization which is called Optica, formerly OSA, and we talk on behalf of our president, Michal Lipson. This is our Corporate Engagement Council. Many big names that you recognize very well. I would like to thank constantly their support. And of course, if you want to know if we were doing it seriously, these people are dedicating their time to us. That means that what we're doing is very serious. I also would like to let everyone know that this meeting is an interactive session. So there are speakers, but each and every one of you will have a chance to speak. Please keep your camera on at all times. Please keep asking questions and please keep interacting with all the speakers today. As usual, we separate our speakers between the integrators adopters, in this case, Everysight, Dispelix, Avegant, and Jabil Optics. They came to this meeting looking for partners, and the companies who are here providing some unique selling points of technology, from Adoptis Holovinyl technology Swave, more photonics pixelating inside, and CREAL. I also would like to remind everyone that we understood the technology of each company in the room today. We took the time, actually, Olga Ras took the time to understand each company individually, and she made this supply chain slide, understanding that all of you play a very important role in supply chain. Please make sure that after the meeting we circulate that slide, that you get in touch with each other. If you want to get in touch with any of the participants today, all you have to do is send us an email, jpod@optica.org, and we'll introduce you to the person you want to get in touch. This is by almost the last but one event of the season. In a few weeks' time, we have our event on OLED and micro LED, which is also very relevant to many people in the room. Please sign up as soon as possible. And if you want to show one slide as corporate member, please let us know as soon as possible so we can schedule that. Also, let me remind you that because you're a corporate member, you can go at any time to optica.org/market reports. Optica.org/market reports. There we have purchased a lot of market reports for you. If you're a corporate member, you have all the downloads you want, all for free, all for you. Just download market reports from Joel, from Tematis. They're all there for you. And finally, last but not least, I would like to remind everyone that this meeting is also live streamed in YouTube. So let me say hello to the YouTubers. Hello, YouTubers in the world. Thank you very much for being there. If you have any question, please write in the chat and I will read it in the room. And if you want to get in touch with any of the participants today, all you have to do is send me an email to the email written down there. And of course, that's also valid for people in the Zoom room. Thank you very much, all of you, for being here. I would like to start. And I think to start a meeting like this, you really have to go to the company that is making a very big impact in the market. In this event, we try to bring as users companies that are really bringing new things. We scouted a company called Everysight a couple of weeks ago. The floor and the attention of everyone goes to Hanan Shamir. The floor is yours.
Excellent. Thank you very much. Let me share my screen. Okay. Okay, nice to meet you all. My name is Hanan Shamir. I'm co-founder and CTO at Everysight. Now, about Everysight, our background, our heritage come from the aerospace domain, and more specifically from the HMDs. HMD stands for Head-Mounted Display Systems, which are actually AR systems encapsulated into helmets. Now, more than 20 years ago, we were thinking how we can take this fascinating technology of AR and transform it to something viable that the consumers may appreciate. And obviously, we understood very fast that we need to encapsulate everything into the form factor of eyewear. Now, when we speak about eyewear, people used to wear eyewear, but they expect and desire for conventional looking eyewears. Now, when we're speaking about conventional eyewears, we actually think about three main objectives or parameters. The first one is the ophthalmic properties. The second one is the safety, of course. It's in front of your eyes. And the third one, of course, is the fashion. Now, when we're speaking about everything, all of those, we expect it to be encapsulated into a form factor which is weight less than 50 grams. 50 grams, we totally understand that this is the absolute maximum weight that the customers expect to find in eyewear or spectacles. Okay, and when we speak about AR, encapsulating AR into an eyewear, and more specifically a mobile AR, which you can take mostly outside and wear it outside and use it outside, then we need to take care, about not just the weight, but also the power and the means for working and competing against the sun. Now, we were thinking how we can do everything, considering that the frame itself and the lenses weight in average 35 grams. If you take an average eyewear that you can find in the market, that the weight over there is 35 grams. So that leaves us to spare for the optics and for the electronics and for the battery. And keep in mind, for many hours of usage, competing against the sun always, okay, which means a lot of photonic power, that leaves us to spare only 15 grams. So how can we do that? Before answering that, let me go over the key factor when we speak about mobile AR. So when we thought about that and designed our systems, we were thinking and designing for a 100-inch full color, and it's important to have a full color TV in front of you, at least 10 hours of continuous operation using battery only. It must be wireless. It should fit both indoor and specifically outdoor, hands-free on the go, in all light conditions. It should not obscure by any means and should not distort, of course, your vision. It should embed in ophthalmic corrections, of course. Again, the full weight of the glasses should not exceed the 50 grams, and the bill of material, of course, should be in the frame that the customers expect, buying plain spectacles or eyewear. So in our system, what we achieved, okay, and this is the glasses, those are the glasses that we have currently available to the market. In our website, you can, for instance, buy them, is that considering the 35 grams, we actually succeeded to encapsulate both the optics, electronics, and battery in less than 10 grams. So we actually achieved the limit and exceed the limit of 50 grams only with 45 grams in total. So how we did it, okay? So the first thing that we did is by leveraging the lenses, already existing lenses in the spectacles. So we have the lenses themselves, the front lenses, and we actually leverage them. And when we speak about the lenses, so again, we have several properties that we need to think about. The first one is the ophthalmic. So when we speak about ophthalmics, we need to embed inside ophthalmic correction. And for that, we leverage the base curve, both the inner and outer, front and back base curves. And we can play with that, both for correcting the display and for external vision. We have prismatic correction embedded inside, transparency, of course. When we speak about safety, then we need to speak about impact resistance, of course, and blocking the UVA, UVB. It's very, very important. And speaking about fashion, just in terms of the lenses themselves, of course, the trimming shape and coloring the lenses themselves, we can play with that. And the most important thing about that is that eventually using the already existing lens is that we can produce them by traditional means. That actually, in that way, we actually leverage that the cost efficiency with a mature industry and the flexibility to choose our manufacturer all around the world. This is very, very important. So how we do that? Okay, so the way that we are doing that is that actually we leverage, as I was saying, that the lenses themselves, and we directly project from the spectacle lens to the eye of the user. We actually use the lens as a spherical combiner, which focuses the display at the user's eye. The way that we do that is by using a free space off-axis optical design, which allow us to shrink down the whole optical solution, and by doing so, we actually minimize the eye relief, meaning that we get very, very small size optics and spectacles.
Contact me. Sorry, I was on a...
Okay, and we avoid the obscurations, okay, by putting the lens or the optics where we do not obscure to the user. And one other benefit that I really proud to share with you is that eventually we can use the same channel in the reverse order, in the reverse direction, and actually look at the pupil of the user. And by doing so, we can track the pupil gaze angle. And yes, and those are the glasses, and we sell them. You can see that. And yeah, if you have any question, I can.
Thank you very much, Hanan, for a great presentation. That was fantastic. Our hopes were very high up. It's your first time at an Optica event, so many of the other people know exactly what's going on. Maybe you don't. You get the Optica question. The Optica question is, what can you do for the others, the other people in the room, the other 131 people in the room? Thank you so much. And what can the other do for you?
Okay, so from our side, eventually we use, common technologies. Starting from the optics, we are using lenses, plastic molded molded lenses. The lenses of the optics. Okay, we have the front lenses where we can produce, and as I was saying, we produce them in a traditional manner, and we have on top of that coatings, and we embed the ophthalmics. So if there are companies that are doing so, we are very much interested to hear about that. We can speak about the display. Currently, we are using a micro OLED display made out from Sony, for instance, and we are happy to hear about more advanced display, micro LEDs. We can incorporate them, and of course, as long as we can achieve the brightness and the size, form, fit factors, we can speak about that. Our electronics involves wireless communication using a BLE. So if there are companies that are doing wireless communication which are low energy and more efficient, we are open to hear about that. Pretty much.
This is a meeting of the minds, Hanan. These people over here, these 131 people that are with you in the room, they are here because they want to work with you. So I'm going to introduce you to some of them. I'm going to go to a beautiful city in the Netherlands called Rotterdam to meet the company Optics. And I'm really happy to have all of them, to have them with me in the room today. Thank you very much, Optics, for being a corporate member of Optica. Frank, you're with us today. Tell me what you could do for a company like Everysight, and what could you do also for the rest?
Thank you. Thank you for that introduction. Perhaps for the rest of the audience, a real quick introduction of at Optics. So we create optical modules with prescription for the AR industry. Our optical modules are primarily waveguide powered. So I think that for any waveguide manufacturer out there, we would love to work with you to see how we can use your waveguide to power our lenses that we directly offer to the market. Same goes for light engine companies. And then, sorry, Hanan, thank you for your overview of Everysight. It's very exciting to see what you are working on. And I believe you use a free space projection method. I would have to understand a bit more about the optical combiner, let's say. So we are focused on waveguides, but we are aware, of course, of the holographic optical elements that can also be inserted in our lenses. So I would need to know a bit more about that if we specifically talk about Everysight.
Frank, as a corporate member, you had the right to show one slide to all of us. I know you prepared one. So let us find out a bit more about the success story from Rotterdam.
Yes, I would love to. One moment. There we go. Do you see my screen?
Not yet. Bottom of the Zoom window, green arrow up, and then you have to select which screen you need to share with us.
Yes, and we're perfectly in the practice session, and here we are. Okay, there we go. I think we should be better now. Can you see my ARX screen? Very good. I'll maximize it. Indeed. So for the general introduction, indeed, our mission is really to accelerate the adoption of AR devices with our integrated RX, so prescription solution, to enable AR glasses for people that wear glasses. And I think there we're really in line with Everysight mission of including ophthalmics. We think the first adopters, not the first adopters, but the first full-time adopters, meaning people who use these devices every waking moment of their life, just like people who wear glasses do today. Those users will, virtually all of them will be people who already wear glasses. So we really believe in that philosophy of using prescription to create a device that is your pair of glasses first, and then an AR device second. So this is a very unique product in that way. It's like if your phone, let's say, breaks, you don't carry it with you anymore. But if your AR device, let's say, runs out of battery, you will still use it all day because it's primarily your glasses. And I think that's a very powerful value that we add to the ecosystem. I think also our timing is perfect as just a couple of years ago, there was not really any glasses out there that look like regular glasses. So it would really be a device that if I would wear it and walk into a room, people would right away say, hey, what's that on your face? And if we look at the glasses that have come out over the last 24 months, it's very exciting to see that they just don't stick out anymore. They really look like regular glasses. But what's missing in Adoptic's opinion is really the prescription part. And that's our primary focus. We're able to do this because of our strong background in prototyping. So for us, prescription is nothing more than a very large number of different designs. And of course, that flexibility in design also translates to the form. So that's another second point that's very important to us, that it's fundamentally impossible to create a single pair of glasses that everybody likes. Just not possible. There's, of course, some form factors that a lot of people like. But if you look at the industry and if you look around you in the world, there is so many different forms that match different faces, different preferences. And that's a second really strong point that our let's say background brings with us, because a future of AR cannot be a future where you wear a pair of AR glasses, you walk into a room and 30% has the same pair of glasses as you. That's not how glasses work. They're in the center of your face. They're part of your identity. So having both the prescription part and the customizability part, I think is really our very our strong point.
How close are we to have these lenses in the market?
Very close. You can actually purchase them from us today already. We have been not very public with it. That's very soon to come. But for let's say the partners we work with under NDA, we can already sell you prescription glasses with a very large range of diopters powered by waveguides. So there's a lot going on. I think at CES we'll have some very exciting stuff to show. And then our core strategy is really to work with a large range of waveguide manufacturers and a large range of light engine projectors. Because
raise your hands. Who's going to be at CES this year? Who else is going to be at CES? I'm going to be there as well myself. So is, thank you very much, Frank. So is the next company I want Hanan to meet today. They are coming from Poland, and this is a company I joined Optica last week. The company is called Inside. Thank you very much, Dziękuję bardzo, Maciej, for being with us. Tell us a bit more about you and how you could maybe support Hanan with the eye tracking.
Yeah. Thank you, Jose. That is very, very, very warm welcome from you. Let me share my screen so I can present with you Inside in the more details, guys. So hello, my name is Maciej Kosowski. I'm a CEO of Inside. Thank you for joining the session. I believe that Optica is super lively group of people, and I'm really glad that Inside has joined this group. So as you see, we are having a new approach towards the eye tracker. So when you believe that eye tracker is a new must for AR and VR and XR industry, once the Apple has shown us the Apple Pro a couple of months ago with the eye tracker that is not additional, with the eye tracker that is not nice to have, it's a it's a full-time piece of device, and it gets input to the spatial computing. So what you see, what we bring to the table, it's a eye tracker that is completely new way of doing an eye tracker. So there is no camera. Because there is no camera, we can have a very low power consumption of 5 milliwatts. We can have a very high sampling rate with 1,000 hertz. We provide zero latency, and the BOM is just $5 or below. Thanks to that, also we will have a very limited or very small impact on the CPU consumption. So with this one, how it works? Because you may ask the simple question, how it works. So we use very simple photosensor hardware. So we have photosensors, AR emitters, and thermistor. So this is very off-the-shelf components only. So there is nothing that you are not able to buy from the market currently. So this is A. And then the whole secret sauce, as people used to call it, lies in the AI software. So we are blinking with the light to the eye with the emitters. The light gets reflected and emitters capture it. Different parts of the eye reflects differently. That's why our AI model will calculate. We don't observe where people look. We calculate where people look. And as you are having 3 patents granted, a couple of more in the production, and 5 pending. So this is the insight in a nutshell. We can be used not only in XR AR industry, but we can be used also in medical sphere. We can be used also in the smart glasses with the native load monitoring for a full day. And with those features, we strongly will contribute to what Jose was mentioning in the very beginning, that one day the smartphones as we know it will be just obsolete, because people will not like to bring those bricks with themselves. They will just have the pair of nice looking AR glasses. And to Hanan point, we strongly believe in your insights, in your dream. It should be light, it should be looking nice, it should be like you need to, in AR glasses, you simply need to look better in AR glasses versus no AR glasses. So we see this is important. Consumption of power, this is crucial. The batteries are of a very small form factor, so this is the way forward. And our small form factor can fit into to the AR glasses of the future.
Hanan, sorry to put you on the spot.
IR domain?
Yeah.
Is it for the IR domain? Are you enlightening the eye with IR, near IR light spectrum?
Yes, it's infrared spectrum. Hello.
Infrared spectrum, yes.
Okay.
Piotr, our CTO, join us to pick up all your.
Piotr, don't be shy. Switch on your camera, or you look great in the picture. Hanan, is there anything you could do together with Insight?
I'm in the car, so I just wanted to know to keep this visual part of myself. But yeah, I'm here with you, so I could address any of the technical questions you might have.
Drive safely, because I see you're the co-pilot and not too worried. Hanan, sorry, is there anything you can do together with Insight?
Yeah, so I will just try and contact you, and let's speak further on. I think that it's very interesting, obviously.
In the meantime, we have a couple of questions in the room, so let's start. And I go all the way to Munich to meet a company called Delo, that they make one of the best optical adhesives and other materials. Thank you very much, Stefan, for being with us. What's on your mind?
Yeah, thanks for the praise, Jose. A question to Frank from Optics regarding the RX. Because cost is always a very important factor for every AR solution. So how is this manufactured? Is this an injection molded solution, or is it similar to Luxac approach of inkjetting? What is it? How do you make it?
Thank you. Very good question. It's an in-between method. You just mentioned Luxac. What they did is directly 3D printing a lens. We believe that's not scalable enough. The other hand, injection molding is actually only makes sense for very large volumes. We really found a sweet spot, which means that we use 3D printing to create a mold very rapidly, very cost effectively. And we combine this with proven traditional casting to quickly create the lenses, but also do this at reasonable volume. But really is the best of both worlds. And that's why it's perfect, we think, for AR glasses.
Do you do any processing to this mold? So is this like you have one diopter, two diopter, and then you can do anything in between by post-processing, or do you have for everything you have a separate master?
We indeed. So our molds are so effective that actually the whole post-processing just complicates the whole manufacturing chain. So the lenses we make just come out of a mold ready to be used. So for us, it's just way more cost effective to create a very large number of molds. That's what we're very good at. That way we, work.
Awesome. Thanks.
Nope.
I would like also to bring the floor another person for discussing. Alexander Loslin from ALOS. Are you with us?
Good afternoon, good morning, and good evening.
Good afternoon, Alexander. I was with you only a few days ago in the other side of the world in Silicon Valley and talking about data con telecom, but you bring micro LEDs also and LEDs also to the AR VR market. And I think there are two companies who presented already who could very well benefit by talking to you. Alexander, could you tell us what you do?
Yes, thank you for giving me the opportunity, Jose. So our company is making gallium nitride on silicon wafers, and that is basically the foundation for all micro LEDs. And the advantage we bring is that these can be processed in large silicon lines, 200 and 300 millimeter, so that you can tap into the manufacturing excellence of those of that industry and make the chips with extremely high yields and at low cost.
If you want to get in touch with any of the participants today, you have to send us an email and we make the introduction. Alexander, we're going to come back to you in a second, but now allow me to give the floor. You know, this job becomes a pleasure when you work with your friends. I want to give the floor to a very dear friend of mine. It's been 2 years since he moved to the company Dispelix. I hope these 2 years have been as amazing as you were with the previous company in the micro-optics revolution. Pia Harju, all the way from beautiful Finland, the floor and the attention of everyone. Thank you so much for being here. The floor is yours.
Thank you very much, Jose. It's actually very nice. I see a lot of familiar faces here, but also some new faces. So
time flies. Already 2 years since you joined Dispelix. How has it been, more or less? Are they treating you well?
It's about 2 years. And but in the benefit of those people who do not know Dispelix, I would actually like to say a few key facts. You see them on the screen there. Dispelix is a waveguide combiner designer and component supplier. Our components are diffractive surface release gratings, and they are made out of high refractive index in organic material. I very much agree to what Hanan was saying about from Everysight about these eyeglasses that are consumer glasses, and especially about the weight. There's another topic what I want to discuss or to show you here today, and these are that we believe that the user acceptance strongly depends on how the device looks and feels. So basically different kinds of comforts. And we have defined some of these comforts for social, wearable, and the visual comforts. And how the waveguide combiners are designed, they play a big role on these comfort levels, and also their design supports all these different comfort aspects. And I have a few slides on these. The social comfort that we look at topics such as aesthetics, eye contact, and privacy. Our target, of course, if you want to have these all-day wearables, that the combiners are transparent, and here the materials plays a role. Also, the grading structures and all the grading, the footprint of the grading needs to be as small as possible. For the aesthetic, we also include pantoscopic tilt and frame wrap, and so that to get this feel of more natural look and feel. In a social setting, when you're talking with somebody, even if you're wearing AR glasses and you're looking some virtual content, you should be still establishing this eye contact. And, that's also a big part of it, and having this social acceptance. In this image that you see in here on the right-hand side, my colleague Hanan, she's wearing our demo. It's a photo, and she was actually looking at the virtual image when the picture was taken. And you can hear, now I'm proud to say that we could reach the target of the world side leakage below is almost non-existent. So this is also a really good improvement in the waveguide combiner grading designs. Then if we look at the wearable comfort, we consider things like the weight and the balance, which like how easy is it to wear, and then the eye relief topic. The eyeglass industry has already perfected the wearable comfort very well, and therefore we try to follow this as much as possible. They have established the designs for the weight and balance, and only thing how we try to also improve or just to have our design so that we have our in-coupling gradings. This is the grading where it gets integrated with the light engines. So we positioned that on the kind of temple on the top corner of the combiner. This also eases up the integration. That you can also see some of the designs that are here on the top by the eyebrows, but we believe that the on the temple that's a good position for the IC gradings. Then for visual comfort, we look at things like eye box size, the virtual image, and the brightness. The eye box is the area where the virtual image can be seen, and it's important that like if you have to move the eyeglasses a little bit, that you still see the virtual image. Sometimes if you just like, let's say I'm wearing glasses, and sometimes they are not always precisely in the same spot all the time. So that's the reason why we think the eye box needs to be large enough so that you still are able to see the virtual image even if you move them a little bit. The brightness is important. Like when you see the virtual image in the daylight, if it's sunshine, you should still be able to see the image. And for the sharpness, which we call MTF, that also needs to be high enough that if you have text or any kind of small objects, that you're able to see them properly and read if it's a small size. Broad compatibility is also important. Let me give you an example. For example, we have a standard waveguide called Selva, and it supports both monochromatic and the full color sources. It also supports wide range of field of views, so one and same waveguide design. And you can also utilize this one for monocular setup or binocular setup. And this is kind of like how we think of our standard product approaches. So we need to have broad enough compatibility that that not everything needs to be custom designed. The Dispelix waveguides, typically they accommodate variety of light engines from DLP, ALCOS, micro LED, and LVS. And if we look at the eye box now in the compatibility point of view, not on the visual comfort, as I mentioned in a previous slide, we know that we humans, we come in all shapes and sizes, and we have a different, let's say, face forms, and our interpupillary distances are different. So with the eye box, meaning large enough, we can also accommodate with one waveguide combiner design, also a larger user population, and then still provide the visual comfort and preserve that. Also, this is the next topic is the eye relief, and this is something that Frank already mentioned a little bit on this topic like prescription and adding vision correction is important, and therefore also in this broad compatibility thoughts, we need to make sure that there's enough room for the people who need a vision correction and we need a prescription added with the waveguide combiner. And I guess I just want to close into saying that we are not doing this alone. I mean, all of us, or most of us who are in this call, we participate one way or the other in this industry, and it's really together that we, elevate the AR market. And so maybe if I want to go into what are we offering and what are we looking at? So basically, I'm already using Jose, your questions. So Dispelix, we offer waveguide combiners, for developers and software also developers, some evaluation kits as well. And we're looking for different partners, from material suppliers to all kinds of technology creators, especially the ones that are very close to the waveguide. And maybe even just to throw out a question that can be maybe used later. I was discussing previously, like, do we already have a least viable product for all-day wearable? Does that exist already, in your opinion? And if no, what are still the missing things? Is it technology, apps? What's missing in order for us?
I think a price point. This is what is missing.
Yeah.
Because I know there are quite a few products, but I think the price point might still be a topic where we should go a little bit down to really make it easily affordable and for the wide application. Thank you very much, Pia, for the presentation. I think, when you said in your first slide that I'm not sure if everyone knows who Dispelix is, let me introduce myself. I think everyone in the room knows who Dispelix is. So I'm happy that you joined us for this presentation, for this meeting. And actually, in terms of the technologies that you mentioned, that materials and of course how to produce it, I know that there are partners in the room, and I even know that you already have heard of one another and possibly worked together. So then I would like to bring up all your actual partners, either already existing or future, to the discussion. And one of them will be actually NILT, who is, of course, the world leader provider of the excellent masters for the waveguides. Niklas, could you please, unmute yourself and just share with us what are the advances on the NILT side in terms of the delivering the best possible masters for the waveguides.
Absolutely. Thank you for the introduction. So my name is Niklas Hansson, Head of Application Engineering at NILT Technology. And at NILT, we manufacture high quality masters for manufacturing waveguides for the AR industry. And we can add different type of structures on these masters, such as blaze gratings, slanted gratings, binary gratings with high precision. And we also bring a lot of design flexibility with us. So it's possible to, for example, select both the blaze angle and the anti-blaze angle. You can combine all the different type of gratings on the same master, and you can also vary the depth in the grating across the grating area. We can also provide replications and working stamps in different materials and form factors. Another part of the AR industry where NILT is active is in the modules, and modules based on meta-optics. So NILT can design, prototype, and mass produce meta-optics in-house. And we use that in order to manufacture projectors and cameras for 3D sensing, and also miniature eye tracking modules. And what is common for these modules is that we shrink the number of optics in the modules. So very often we have modules consisting of just one single lens on the emitter side and one single lens on the receiver side. And what we are looking for is, it's both partners in terms of material suppliers for making device replications, but also partners for making integration of meta-optics in modules, and of course waveguide manufacturers and end customers. Thank you.
So, Pia, thank you so much, Niklas. So, Pia, does it sound like a good partnership on your side? I'm sure you're working together.
Let me put it this way. I think Niklas is a good friend of mine already, so we know each other.
Yes, and I know that you're almost neighbors, right? Because you're in the Niltes and yeah. So very close to another. And speaking of the materials, actually, for both of you, there's another excellent partner in the room, which is Pixeligent. And Peter, I would like you to join us, and the floor is yours to present the what do you have on the material side for the excellent quality waveguides.
Great. Thank you very much for the introduction. Hello, everybody. Yes, I'm Peter Guschel with Pixeligent Technologies. Basically, my company has been in the this universe for a couple of years now, ever growing and making more and more friends and partners along the way. But mainly, we are a nanoparticle formulation company. Our excellence is making these very controlled, well-dispersed nanoparticle systems, and we've of course been focusing on our many product lines, especially the PixNil line, into the nano imprint world, using our PixClear Designer Compounds technologies. We are also in other industries as well. PixJet gets into inkjetable applications, and obviously we are working very hard to get that type of technology into the nano imprint world as well, to help address that material efficiencies and cost efficiencies that everybody's very much interested in. So our PixNil formulations range in film refractive index from 1.7 to 2.0. This is again very important for matching the substrate refractive indices as people are trying to get the best field of view. We pride ourselves in making very high transparencies, low haze type formulations and films that allow for minimal optical losses in these applications. Our core nanoparticle sizes do range depending on the metal oxide system we're talking about. We currently work with zirconia, titania, and then even our new core shell concept, which is a titania core and zirconia shell. Trying to, again, maximize on refractive index and maintaining good stability under light exposure, specifically even UV, while still managing very good particle size distributions of our nanoparticles and the formulations themselves having very good shelf life and pot life stability. Some of the features that are really great for our technology, and I think the pictures say 1,000 words here on the right, with the capability with our partners to already show we're making these waveguides, we're making the structures that people care about with the slanted gratings, and we're even showing at the bottom there just how well our nanoparticles can be packed and distributed within these structures. I do highlight there that residual layer thickness to the left, showing about 31 nanometers, which is actually about 3 of our nanoparticles tall. So very excellent to show these types of results and how we maintain no phase separation in these structures and help to get the best properties and performance that they can be. So we've already been demonstrated binary, slanted, blazed, high aspect ratio gratings. Please contact us if you want to see more information about such things. We've proven the low residual layer thicknesses that are capable with our formulations. We are manufacturing ready. We can certainly work in the multi-ton capacity. We're in Baltimore, Maryland, by the way, if you've heard of it. We're just north of Washington, D.C. And ultimately, why does this matter? I think you all know it. So high refractive index really helps to drive the field of view and fully immersive AR/MR experience, and we're here to help. And we all know that this nil process is the way to go, and we're happy to partner and work with everybody to make it a reality. Thank you very much.
Thank you very much, Peter. So, Niklas, Pia, how does this solution sound?
From my part, I think it's very interesting, and yeah, I would love to test out to see how the imprint would work with this material.
I'm sure you can connect after the meeting. We'll make sure to forward the contact. Pia, what do you think? Does it sound like an interesting new material to try, or have you worked together before?
Very interesting material. Also like to understand a bit more of the processing of it. But yes, thanks very much for sharing that.
Thank you. Thank you. I know we've overlapped in the past, and I think we need to touch base again for sure. So thank you very much for your audience.
Peter, we actually have a question to you from the applied materials. So Gautier has asked, Gautier, would you like to maybe ask the question yourself? In this case, please unmute yourself and ask your questions from applied materials.
Yes, hi everyone. Sorry, I don't put my camera. I'm in my garden. But yeah, I was just wondering about the aging of your materials. Do you have like any kind of, I don't know, not numbers or study, but does the MTF or efficiency or color uniformity is affected by your waveguide over time? Like typically my question is how your material is aging over time, like.
Is this specific to any certain reliability conditions you're talking about, or just sort of?
Not especially, but you know, like in the market, we have already seen like a couple of waveguide using matters, and you have this yellowing effect, and you have the brightness which is destroyed over time. So I was wondering, like, if you have like another formula, or is it like kind of the same?
We have many formulas, so it's a difficult question to answer generally speaking. But ranging between our zirconia systems, which are very stable, zirconium dioxide is not typically a yellowing type of nanoparticle system. Titania certainly has its concerns with photostabilities, and then again, this core shell, what we see the PIX core name in my slide that covers a solution to improving titania while still maintaining very good refractive indices. But reliability is very important to us, and of course we have data to share even under more accelerated conditions. So I'd be happy to share that information with you after.
Great, thanks.
Okay. And I actually wanted to because you both mentioned that it's important that you not only not only the material but also the technology that you use to produce it. And I guess the nano imprint became very popular technology for this, and we have an expert in the room for this. And I would like to invite to speak the Erkan from Morphotonics to tell us more about their nano imprint solution. I know your motto is any optics, any size. Please
any display. Yeah,
any
exactly.
Display.
Thanks, Olga. Hello, everyone. There are lots of people that I know personally and through Morphotonics. So thank you for giving us the opportunity to talk today. I'll share my screen quickly. So we are Morphotonics based in Eindhoven area in the Netherlands. Indeed, our motto is any optics, any display, any size. And we consider ourselves as pioneers in what we call the large area nano imprinting. And specific to augmented reality optics, we believe that we have a scalable manufacturing solution. If indeed we are going to get rid of the bricks and start using glasses as a medium for doing our daily compute, daily interactions and communication, then we are talking about having millions of these devices around the world. One of the key parts of augmented reality glasses is going to be obviously the glass itself, the optics themselves. And as it is a large piece of glass, considerably, manufacturing it also requires quite a bit of efforts and time. And we believe that by having a mind shift from a manufacturing mindset shift from a semiconductor-based manufacturing method to more of a display manufacturing mindset, which is what we can enable, then you can really increase the throughput while keeping the quality and reducing the cost. And that's what we show here. Indeed, pictures speak 1,000 words. So what you see here is actually a work we have done with some of the partners in the room, including NILT. Also, we have used resins from Pixeligent in the 1.9. We took one single eyepiece master that's on a 4-inch wafer, and here you see a Gen 5 imprint, which is 1.1 by 1.3 meters, where we are able to replicate 480 of such devices. And here I actually have one of the quadrants, if you will, in my hand, where there are 30 waveguides in a 6x5 configuration. Okay, so that is what we can bring to the AR field. What do? We are an equipment supplier. We are an original equipment supplier for large area nano imprinting. We have a commercially proven technology. Our products manufacture optical parts that are built inside products. They're shipping. You can buy them on Amazon. Specifically, I'm talking about a 3D tablet by a company called Leia, which is an HP spinoff, who is one of our customers that we can speak of. And our main focus areas are three in the display world. One is augmented reality glasses, obviously. Another one is glasses-free 3D. And the third one is what we call anti-glare. So having the sunlight readability on your mobile devices, we believe is a key element and a pain point. And these are the three areas that we are focused on. So our motto is indeed any optics, any display, any size. So going back to Jose's classic by now, what can we do for others? We can help you with nano imprinting at scale and bringing your manufacturing of display optics at scale at a lower cost with high quality. And what you can do is you can help us get there. And there are many partners in the room that we are already in discussions with, but we are happy to have further discussions with others. So reach out to us. Morphotonics.com is our address, and you can reach out to us at info@morphotonics.com. Thanks.
Thank you, Erhan. Actually, quite a few people are asking the questions about the materials and what is available. For instance, one of them is from Arne Schleunitz. Arne, would you please unmute yourself and ask your question?
Olga, many thanks, and also Jose, many thanks for the organization of this wonderful event. I'm happy to see so many friendly faces that I know of. For those of you who don't know me or microresist technology, we do offer photoresist and photopolymers for many, many years. So we do take part in this AR, VR journey, but not so much when it goes in the direction of direct imprint of high refractive index polymers, like Pixeligent just nicely introduced, but more when it comes to the situation when you use nano imprint lithography and paratransfer into inorganic materials, for example. Pia also mentioned that in her nice talk. So that's why I was just wondering and wanted to address Pia, if you can give a comment. You also said that you want to reach out to further material partners. We have so many material partners in the room. Can you enlighten us a little bit about the missing links that the ecosystem right now is not able to supply to you, or are you fully satisfied? That's just my question to Pia and to companies like Dispelix alike.
I think so currently, we are already producing waveguides. We have our standard products, but also if we extend what I wanted to say is I saw a presentation about a year ago where a material supplier showed where they would add transparent conductive materials, and they beautifully utilize this one for example, you could utilize this in the waveguides for add some additional functionality. So I think what I also want to see, like keeping the mind open to look how you can innovate with materials. And I think also when not only the gradings, but what else can you put in there? And I think here the materials play a key role.
Okay.
Do we have anyone in the room that does transparent conductive materials? Raise your hand. Well, then maybe we need to find for new partners that are doing this. We actually have another question from Ralph Knoll of Inoptech. So Ralph, if you would be so kind to unmute yourself and ask your question.
Yeah, thank you, Olga. I've been in the AR industry also for many years, and we keep seeing a design trend towards these allegedly more fashionable, slimmer temples. And we made some measurements, and whenever a car tries to take over and they put the high beam up, so they do this flashing when they want to overtake, the light comes actually from behind, and that actually destroys the picture of the AR display. The same is true for deep standing sun behind you. So long story short, my question to everybody here who's building AR displays, is that a problem or isn't it a problem? We want to build light tight glasses, but it seems that the fashion trend is so strong that everybody is making a bet on open glasses, which I find quite brave. So what is the opinion?
That's the business of the bold. Who would like to address? We have quite a few people doing displays. Tomas, AK, Pia, who would have a comment? Hanan, what would you say? You know, you're the farthest there. You've released the design. What do you think?
So at least our design is what we call, if I understand you correctly, those are considered open design, no? Or
yes, your design is considered as more or less open, as long as you don't have a flap here on the side which shields the whole eye from light coming in.
Exactly. Let me share with you that actually one of our partners, which is already published, is BMW. So they are using that for motorcycle drivers. So obviously they cannot block the visual from the sides. Okay, it's a matter of safety. So this is why we actually left that portion of obscuration empty, allowing as much as possible a field of regard. And it's very, very important. Once you are speaking about mobile AR for the consumers, you must think about not just weight and obviously cost and obviously to work outside, but safety. Safety is one of the most important aspects that you need to take care about that. And together with that, to withstand environmental conditions, meaning impact, meaning rain, meaning sweat, meaning chemicals that touch the. So once you speak about that, you need to think about mobile AR for the consumer world. So obviously, yes, open frame is something that is necessary.
Thank you, Hanan. I think, Ralph, I think it will be interesting, very interesting question to address for the virtual reality, where there it's the consideration of safety doesn't become that much of issue because the target application is different. I guess there will be more important the design, but this is just my thought on this.
You're completely right. We are going in a slightly different direction, I guess. We have more curvature. We can do base 4 and base 6, and base 6 looks almost like a mountain bike glass. And they have also very good opening peripheral vision. It is 120 degrees field of view if you go base 6, and we have very good experience, and it's still light tight in our case. So let's see how it works.
Let's see how it works. But nevertheless, while we're already going into the designs, I think still, as we all agreed, we still believe that, not believe, but the industry tell us that the slimmer design, the more elegant design that your way far from Ray-Ban will still look like a way far from Ray-Ban, is there where everyone goes. And I think here, one of the key aspects is actually the dimensions of the light engine. And I think for this, I would like to basically enlighten us and cover us on the topic of the most advanced light engines. I would like to invite Edward to the room, who is, I think, now on the front lines of developing the smallest and the most elegant light engine. Ed, the floor is yours. We're all very much looking forward to your presentation.
Thank you. Thanks a lot for having us, Olga. It's good to see a lot of friends on the call here. So I just wanted to quickly introduce a little bit about what we do today at Avegant. So my name is Ed. I'm the CEO and founder of Avegant. And I think we all know that when we look at augmented reality glasses, we're trying to achieve the smallest, most consumer-friendly form factor possible. And I think what many people don't know is that the single largest component, both dimensionally, tends to be the light engine. And so the smaller that you can make a light engine, the smaller you can make a pair of glasses. So if you look at this image here, you can actually see one of our light engines embedded in this frame. Now, this is what we do for our customers. We help our customers enable true glasses-like form factor with very small light engines. There's been a lot of work, obviously, with fantastic waveguide technologies, very thin, very efficient. Electronics are all shrinking. But the light engines themselves still tend to be quite a limitation to how small you can make these glasses. And to do so in a very manufacturable way while maintaining the performance is one of the key challenges today that's holding up the AR industry. So what actually we announced earlier this year is the first product that we're bringing to industry today, to the market today. It's called the AG30L2. You can see an image of it right here on the upper right side. It actually is about the size of half a sugar cube. So it's very, very small. And what we're starting to see in the industry is that for the foreseeable future, the industry is predominantly focused on shipping LCOS displays. And the reason why LCOS is going to be such a dominant technology in the for the foreseeable near term is that people need technologies that are mature, high quality, manufacturable, and low cost, while still maintaining the performance necessary. And out of these LCOS engines today, we have the smallest LCOS that is shipping. And more importantly, we're actually in production now. So we have many thousands of engines that are being manufactured and sampling to a lot of customers all around the world. And just some high-level specs about this particular engine that I'll highlight. This particular engine is focused at a 30-degree field of view. Obviously, it is a full-color LED illuminated engine. It's a square 1:1 aspect ratio. It achieves about 34 pixels per degree with 720 by 720 usable pixels. Now that we're seeing waveguide efficiencies really start to increase quite a bit over the last year, and we expect that to continue to increase, we do spec a nominal light output at 2 lumens, full color, D65 white point polarized. We can hit 4 lumens as well. That's the maximum light output in full color. Now, if you assume your waveguide is, let's say, at least 500 nits per lumen at this field of view, that basically means that nominally we can hit 1,000 nits to the eye in full color, or maximum over 2,000 nits full color. And we're able to do that with about 200 milliwatts of illumination power. So incredibly power efficient as well. We also have the ability to run it with fewer colors, 2 color or even single color, when you really need situations that are super high brightness. For example, outputting over 6 lumens in a single color would allow you to hit 3,000 to 4,000 nits to the eye with most waveguides. The volume that we're hitting is about 1.2 cc's, and it's quite a light engine at about 2.7 grams. These volumes and weights include everything. So it includes connectors, electronics, any kind of flex cables, LED drivers, thermal interfaces, thermal modeling is all done in this. So it really is a turnkey solution that we're seeing a lot of traction in the market today. And how do we do this? Well, we are fundamentally a light engine company, and obviously we work a lot on optics, but there's other technologies that we work on as well. Anything to do to try to achieve the smallest and most powerful AR engines in the market. Of course, we have a lot of efforts in the optical architectures. One of the key things that we do in order to shrink the size is have a completely different approach to how we design these optical architectures, particularly for LCOS engines. So one of the big differences that we do is we don't utilize PBS cubes. So no polarized beam splitter cubes, no cube with this diagonal polarized film in the middle. And one of the reasons why we've been able to eliminate that, or why we choose to eliminate that, is the PBS cube tends to be one of the largest and heaviest component inside light engines. They also tend to be one of the most expensive single optical component inside a light engine. And they also limit the field of view as you grow larger. These PBS cubes tend to sit right on top of the LCOS panel, which means that you end up with this back focal length limitation of how close you can get your optics to the surface of that panel. And by eliminating this PBS cube, not only can we make things smaller and lighter, but they're also more inexpensive, and it allows us to get to larger fields of view without increasing the without increasing the volume of the engine. So today we have 30-degree engines, but we also have worked on 50-degree engines that are basically the same size as well. And most importantly, for our customers who are planning on shipping products in the next 12 to 18 months, these technologies are already in production today, and we're already sampling for a lot of customers. But beyond the optical architectures, we also work on software and hardware. I'll give you some examples. And even in the software space, we give our customers the ability to change the performance of the engine on the fly using custom software and firmware as well. So if you want the ability to be able to change color fields on the fly, let's say changing the sequential field rates by between the RGB, or even from 3 colors to 2 colors or 1 color, we can have software-defined performance that allows our customers to be able to change and optimize the performance of the engines, not just for their product, but in real time for their situation per their environment as well. And lastly, we also work closely with our customers and even upstream with SoC manufacturers to try to find ways that we can help reduce power overall in the system. For example, we've been able to incorporate things like freeze frame controllers, where we can utilize the memory buffers and hardware architectures to be able to hold images inside our light engine. To give you an example, one common application that people look at is things like AR navigation. So if your glasses are going to say, hey, you need to turn right ahead, instead of showing you an image that says turn right for 5 seconds, and generating 60 frames per second for 5 seconds, you no longer have to generate 300 frames coming out of your SoC. Now you can generate a single frame and then shut off your SoC, and we can hold that inside our controllers and engines. And so that's a significant power savings on the compute side as well. And so not only do we work with a lot of the tier ones, the largest consumer electronics companies in the world, we also work on a lot of reference designs. And here's an example of some reference designs that will be available to the market early next year. This is an actual image of something that was built, very small, very light, stereo binocular displays, fully wireless with incorporated sensors and SoCs and battery powered. But these are the type of products that you're going to start to see becoming available and in the market starting next year. Thanks for having me. Any questions?
Thank you very much for being with us. This is great. We are really looking forward to connect more and more companies in the light engine side. What you're doing in the field of LCOS is fantastic. We have actually corporate members who are supporting this technology, and I would like you to meet them. Before that, we have a really important question in the room, which I want to address as soon as possible. So let's go back to Veldhoven, just outside Eindhoven Rock City, and give the floor back to More Photonics. Erhan, what's on your mind?
Hi, Ed. Long time no see. So the question is, Ed, do you see micro-LED-based light engines as the main competition to what you do? And if so, when do you see the competition to become more fierce? Is it 2-3 years out, or?
Yeah, I think that, assuming that everybody is going to be using waveguides in AR, which I think is a safe assumption, you really need a display technology that is bright enough to be able to power waveguides, which inherently aren't that efficient, right? And so people have tried looking at technologies like laser beam scanning and DLP for a long time. Those type of technologies generally have gone to the wayside. And so people generally today are focused on LCOS technologies and micro-LED technologies. These are kind of the two technologies that are efficient enough, compact enough, and bright enough to drive AR displays. Now, obviously, there's been a huge amount of investment in micro-LED technologies, a lot of acquisitions in the space as well. We're a light engine company as well, so we work on lots of different micro displays. So we're not specifically tied to LCOS. But what we're seeing today from our customers in the market is that LCOS will likely be the dominant microdisplay technology for 5 to 10 years. And the reason why is simply because of the maturity of the technology. We think that there's a lot of potential for micro LEDs itself, but I think what the industry is seeing today is that not only are there challenges in yield and manufacturing, trying to get all 3 colors on a chip without using X-cube combiners, and cost is a major problem right now in micro LEDs. And so what we're seeing from our customers, what we're seeing in reports from companies like Yole, is that LCOS will likely be the dominant technology through 2030.
Thank you.
I would like to thank you even more, because what you just said makes me very excited, because I would like to ask Alexander Lossing. Alexander, you just heard the statements from Edward about the problems with yield and production of micro LEDs. Where do you stand on this?
I'm happy because I think the biggest challenge is actually overall for the industry to get these light engines and everything else with it. I really enjoyed Hanan's talk at the beginning. Very impressive, yeah. To get them into the right form factors so that there's products and people adopt it. Overall, from all what I know about the technology, is that micro LEDs in the end have significant advantages for brightness and efficiency. And when we then think about the lifetime of the battery in these kind of applications, I think that will be a key factor. And we do see significant progress on the cost and the yield for micro LEDs. Yeah, in particular, when you bring these to silicon lines, you have completely different levels of yield and cost comparing to what you have in LED lines, where today micro LEDs are made. Right, there's very few people out there with demonstrators who have made micro LED displays for these small AI applications with micro LEDs. And you will see some interesting news early next year from one of the key players. And I think that will give us more speed than the 5 to 10 years Edward was talking about. Yeah.
I thank you very much, Alexander, for being with us. Edward, allow me to bring you to one of our corporate members. We go to Berlin. We go to meet the company HoloEye. Tobias, thank you very much for being with us, and tell us a bit about how diffractive optical elements and special light modulators can play a role on this field.
Yeah, thank you. Let me quickly share my screen. Where is it?
Bottom of the Zoom window, green arrow up, and then please select the screen you're going to share with the world. You know the deal.
So, do you see it? Crystal
clear.
Perfect. Well, thanks for introducing. So, yeah, we heard about from Edward about Avegant and the super small light engines. HoloEye is a company that consists of 3 business units. So we have micro displays, LCOS based, we have diffractive optics, and also spatial light modulators, where we make use of LCOS based micro displays, but for phase only modulation applications. So I would like to introduce or to present a display that we have and that can be used. It's 2220. So it's a full HD display with an integrated driver in the backplane. So it's a more or less one chip solution. It has a pixel pitch of 4.5 microns, and it's about 0.4 inch diagonal. As you can see, the power consumption is also quite low, and especially at in standby, where, well, in an application, you don't always have the image information showing at all the time. But it also, you want to make sure that the display turns on at the exact moment when you need it and doesn't consume a lot of battery in between. What I want to highlight here is that HoloEye is able to provide custom solutions. So we are able to provide different package formats. So we can start on the wafer and design a display that fits the needs of the applications. So let it be a certain contrast or a certain response time. So there we can, we are open to design, and especially to have, to give you a starting point. We provide development kits. So I think that's the point to start from. And when it scales up, we are partnering with OmniVision in this case. So it's possible to have a large volume production as well.
Thank you very much for being with us here. I would like to go back to Edward. Edward, you just see this LCOS microdisplay technology. What is the first thing that comes to your mind? You are here today playing the role of an integrator or enabler.
Yeah, I think it's always interesting to see a lot of the LCOS developments today and from companies like that. And, one of the things I think we're seeing a lot is a lot of advancements in the LCOS backplanes. I think we're going to see a lot of interesting products coming out next year, which much smaller pixel sizes. Yep.
Can I call you back? Sorry.
Oh.
So that was Sony. We allow Sony to do anything they want at this meeting. Just so you know, Edward, that's how we play it here. Rudolf, I'm giving you the floor for a second.
Sony makes LCOS panels too.
Yes.
But I think we're going to see some really cool, interesting developments in the LCOS space in the next year. Starting with much more advanced backplanes and much smaller pixels too, that they're really going to enable much higher resolution, smaller form factors, and larger fields of view in the very near term. Yeah.
Let me also bring, one thing, Edward, that I'm liking so much about this meeting. So far, it's been great, but you didn't mention the word metaverse yet. After 1 hour and 21 minutes, it's the first time this happened in the history of AR/VR since 2021 that nobody says metaverse. I think this is about to change because I want you to meet one of our recent scouting efforts, Swave Photonics. AK, thank you very much for being with us today. Tell us a bit of what you do and see how you could maybe do some cooperation with Edward, with Hanan, with Pia, and the rest of the room.
Absolutely. Thank you so much, Jose. Thank you so much for having me. Let me attempt to share my screen.
Are you going to say metaverse?
Maybe. It's a very strong maybe. So I think, Edward, you made some very good points that I'm actually going to build upon. So from our experience, the volume of the light engine is a very important factor. And what is pretty much defining the volume of the light engine is the pixel size of your display. So here I'm going to present to you Swave Photonics and our product, which is holographic extended reality displays. So what are we showing? We are showing a spatial light modulator with a pixel pitch of only half the wavelength of visible light. And that unlocks really groundbreaking applications of true 3D holography. So zooming out a little bit, how would you use that display? Essentially, you illuminate it with a coherent beam of light, for instance, a laser. And what happens is the display is now modulating light and forming the wavefront that contains all three-dimensional image. You can then look into that image directly. We have done that as well. But even more usefully, you can relay it straight into your eye, and that enables you to see fully three-dimensional image. Now, at the core of this, there is the material, which some of you, especially the older generation, probably remembers very well whenever you recorded CDs, rewritable CDs and DVDs. So that's this right here. You may also know that the same material has been used in semiconductor memories. So essentially, the material is bistable, which I think it's also a fair point to mention that when you switch the pixel, it does not consume any more energy. So the material is bistable, and by electrical pulses, we are capable of switching it from one state to the other, and two different states react differently to light. Another thing to point out.
Can do it maybe in 10, 20 minutes when you give
Okay, sure. One thing to point out is that our processes actually benefit from CMOS economics. So most of the device benefits from completely off-the-shelf CMOS processes. Well, why do we believe this is so groundbreaking? Well, when you actually look at it, think about 16,000 by 16,000 pixels into the area which is 4 by 4 millimeters, the size of a ladybug. And now I'm going to show you that this could very neatly fit into the glasses I'm wearing right now, which is the dream of the industry, which is
we could not see it. It was too fast. Can you show it again?
Yes, so these are my glasses, and you can imagine how this device can be integrated into the temple of my glasses. And what will come as a result of it is the benefit of holography, which is getting rid of any vergence accommodation conflict, being absolutely easy on the eyes, and the user being able to perceive bright images pretty much embedded into your world.
Thank you very much. And again, let me go back to Edward. What do you think? How does it make you feel, this technology? Is there anything that you could perhaps talking about together?
No, I just have to say, I love all this development in the backplane technologies, like being able to have unique pixel structures, unique ways for companies like us to think about like new optical systems to really improve the performance and shrink down these engines. Are really going to move the industry forward. So I love to see these type of technologies. It's very, very cool.
I would like to also, first of all, Edward, everybody in the room wants to do business with you. So please be aware that there will be introductions at the meeting. For anyone,
Brilliant.
Let me remind everyone, if you want to get in touch with any of the participants today, all you have to do is send us an email, jpost@optica.org, and we'll make the introduction. Tobias, Hollow Eye, there is a question for you here, and the person, even though I asked, he wants to remain anonymous, which most likely means that he's a competitor. That's how you know, Tobias, how this works. The question is very simple. Do you think special light moderators SLM for CGH might be playing a relevant role in augmented reality devices? Is it possible? Is it possibly a scalable technology? To what extent is technology scalable? I think is what he's asking.
Well, we've seen some research recently or some years ago from Maimoni or also from Stanford University showing some impressive results for a CGH calculation and also integrating it into a wearable device. It's hard to tell. It's really not easy to tell.
In a previous meeting, we had VividQ talking about that. We also had a few other presentations talking about holographic AR in that respect. I believe that there is not clear answer there. But in addition, we have another question. Tobias, it's not for you. It's actually for Andre. This question is coming from Applied Materials, AMAT. I'm so happy to have AMAT in the room. Great company. Gauthier, tell us what's on your mind.
Yeah, no, I was just hi Andre, it's nice to see you online actually. I see you are quite
yes.
quite active on LinkedIn, but I can finally speak to you. So yeah, I was wondering, have you tried any integration with the waveguide, and does that work with any kind of waveguide, reflective, diffractive, or holographic?
That's a very good question. I'm trying to see, because in my previous life, I was a part of a different company that actually did the integration of a CGH engine with a waveguide. it is possible. There are challenges, but it's possible to solve them. I am very happy to send you more materials about it. I think I'm not really that comfortable discussing that on the call.
Oh, don't worry, Andrew. This is a private close meeting. Super.
No problem. We can catch up, but I'm really interested because I think it's you know, like people see like many like killer application. Like one of them is the form factor, but I strongly believe that the accommodation conflict is one of them, and it's really important, and people do not take care of it. So
Absolutely. So I think as a part of Swave, we are, because our modulator has so many pixels, I think the waveguides are very, very often used in order to replicate the pupil. Our modulator has so many pixels that I don't think we have a need for that necessarily. We could be compatible with waveguides if we find a need for it. Let me answer it this way. Yeah. Does this answer your question?
Thanks.
Thank you.
Gautier, don't leave me, because not every day I get applied materials in the room. Gautier, it's great to have you with us. What brings you to this meeting? What is the main interest, and maybe a couple of challenges to share with the room that they could help you?
But maybe I can just give you like an overview. So I'm part of the CTO office, and inside the CTO office, we have different groups working on emerging technologies. And one of them is photonics. And so we are developing many kind of different photonic components. So we are leveraging what Applied Material is doing since 55 years in the semiconductor industry. So now it's really well known, but we are working, for example, with Dispelix doing the manufacturing of the waveguide in high volume. And as a product marketer, I'm trying to understand a bit more about augmented reality and how the market will go if one day we have a consumer market. I hope. So yeah.
So I got here. Many people are gonna get in touch with you now that you say that you do manufacturing for Dispelix. But in addition, Gautier, did you know before today? Tell me the truth. Did you know a company called CREAL? CREAL. Before
Yes,
today.
I know our Swiss colleagues from CREAL. I know.
What do you think of them?
I think it's really great what they are doing, because again, like they are proposing like a true way of doing variable focusing, and I think that's one of the key points of doing smart glasses. If you want to access the consumer market, you need to find a way to get rid of a fixed focal plane and to be able to work with the accommodation conflict, divergence accommodation conflict. So I think it's two main things to work on. So yeah, Cyril is doing like a great job at it, I think.
I was just told the right pronunciation is CREAL. Thomas,
yes,
not every day
yes.
you get introduced by Applied Materials. The floor is yours.
It's really confusing, by the way, because you have two Cyril. You have one Cyril in Luxembourg who is doing heads-up display, and one Cyril in Swiss who is doing this kind of product. So please find a way to change your name. I don't know.
And one Cyril here. Bad joke. Thomas, go ahead.
Nope.
We cannot hear you. No, he's not on mute. He's just wearing the AirPods with cable. In the meantime, while he connects the cable.
Do you hear me now?
Yes, now I can hear you loud and clear.
Yeah, that's strange because I stopped hearing you, so I unplugged it and then I couldn't speak. But okay. Well, thanks a lot. It was perfect introduction from Gautier and you, Jose, because it said what we do and also why it is called the See Real. It's about seeing real, right? And maybe before I start saying more about what we do, there was said so many conditions about what the ultimate augmented reality needs that we would have probably a list of like 15 of them. the problem is that it's all right. All of them have to be satisfied at the end. And we are focusing on one of the problems, but of course, have to have a technology that satisfies the rest as well, ultimately. And to tell you a bit more, I will show some slides, or one long slide. Do you see it?
Clearly.
So we care about that vision comfort from the point of view of how real 3D looks like and how the artificial 3D should look like. And as it was mentioned, here we have the problem. Our eyes evolved to see the real 3D world, which is different from how the 3D headsets create the illusion of artificial 3D. Still, everything we can buy provides just the stereoscopic illusion of that. And here is the massive problem. That's not enough. Each one eye can see a depth. And it's important because if it is not there, if we see only a flat image, let's say 2 meters far, we focus on our own hand and we can't see the content. We can't see anything that is closer than that display. And that drop of effective resolution is monstrous. It's like, let's say, from 60 pixels per degree to some 3. And not many people speak about it. Each time the resolution is presented, it's in fact valid only for one specific situation when the eye is focused on a fixed distance. And in the long run, this is not enough. First, it's not correct. You can't see the content in all situations. And ultimately, it's also unpleasant. It creates divergence, accommodation, conflict, and more. So to fix the problem, we can't display just a flat image. We need to provide focus depth. And this is what we do at CREAL, and of course, multiple other companies with a different approach. We have our own. We make a light field micro display that's create the light field perspectives in a sequence. So we have typically 32 viewpoints, which are created 1 by 1 times 3 colors with a projection engine that is based on ferroelectric LCOS. So very fast type of liquid crystal on silicon. And having these many perspectives, entering the eye through many different locations of the pupil, create a complete illusion of the focal depth. So this is just a computer graphics illustrating what you should see and what you will see through our display. You can really touch a bird which is 20 centimeters far. And the next video is the actual footage we take by a camera through a combiner which we have. So right now you can see that the camera focused to some 25 centimeters on the flower and the bird popped up in focus. So that's what we don't get from the classical flat screen-based displays. So you can show content close, even very close. This one is maybe 10 centimeters far. So there is basically no issue with the focal depth. And here is, let's say, one of the many flavors of how the light field display can look like. And this is the one we are actually, of course, focusing most on because it's most advanced in terms of form factor and performance. So it's based on the laser illumination light switch that is creating like many different angles of the light. It is being modulated by our own ferroelectric liquid crystal on silicon and then guided to a holographic combiner on the lens. So it's a free space combiner. And when I mentioned that just creating that focal depth is not enough, you could have a huge box costing 1 million, it won't reach a product. So we have to satisfy the rest. And this setup allows us, of course, first to provide the natural focal depth, but also prescription correction digitally for the content and with a classical lens for the real world, because I will show you then, it's actually normal lens with the holographic film on it. So the lens we buy in a shop. It also has very highly unobtrusive view. You have very little artifacts, like rainbow artifacts. You have very low light leakage out, so you can preserve the eye contact. And it looks normal. It's aesthetic lens with the right curvature. It's proven that people accept it because these are normal glasses. It's highly light efficient. Ed was mentioning 200 milliwatts for the LCOS displays, which is a massive achievement. Problem is usually the waveguide, the low efficiency, and the free space holographic combiner is around 50 times more efficient, or the overall efficiency of the light. So we can get below 10 milliwatts for indoor brightness. The light field or the holographic images are often have often problem with generating the content efficiently. And our light field actually uses the normal content. We can use any 3D content, and we synthesize missing viewpoints with some 10% overhead. And it's based on, I would say, proven technologies. So that's the other advantage. I think I took enough of the time already, and I'm really happy to hear how we can collaborate with everyone interested in solving this problem.
That would be actually the question, Tomas. So what is missing from the side, from the maybe Optica partners that would enable this technology to really work and to see the real life?
Yeah, so first, when I see all these presentations here, I really feel like we are a little bit outcasts because the whole system is a bit different. Every single component had to be really designed specifically. So we need first, I think, from everyone the conviction that this is also the right way. So first, it's not a waveguide, it's a free space combiner, which was already put in production by Intel Wound and North in Focus. So it proved some reliability. And we need, of course, manufacturers and at the end, those who adopt the display for the product. So please write me, let's do it.
Let's do it. Ed, you had now an opportunity, you mentioned that you're, as a light engine company, you're playing with so many different displays. How are these two, the holographic display and then now the real serial display?
If you're familiar with us, you've known that we've actually made quite a few light field displays in the past, as well as optically foveated displays as well. I think in general, there's so much development to happen and innovation to happen in these display technologies that will have to solve so many problems in the future, right? Like today, people just need to get, in order to create the market, right? We just need very small manufacturable displays just to get products out the door. But there are so many fundamental issues that do have to continue to get solved in order to keep getting to the next level of performance. And what CREAL is saying is right on the money, right? To be able to solve vergence of combination conflict is critical to enable the full usable AR space. Vergence of combination conflicts become very problematic when you're within about 1 meter of distance. And 1 meter of distance is where we want to use our hands. So any kind of user interaction type space, you really need the ability to solve VAC issues. Creating these light field displays and waveguides have a particular challenge. So seeing the approach of using these holographic combiners is really interesting. They can be curved, they can be efficient. So it's an interesting approach to see that solution.
Thank you for the comments. Well, now we're slowly moving into the end of the 2 hours, and I think now is after so many different technologies.
I think there is a problem. There's a question, Olga, in the room.
Oh, sorry. Jose, please.
I had a couple of questions, but probably Tomas, I will take your contact because I really would like to discuss the technology from CREAL. But yeah, maybe one question is, so you do by yourself the optimization of the holographic, stack. And second question is, how do you manage, what's the, let's say, power consumption and in terms of computation? Is it something big? Is it do you need, can it be on a chip on the frame, or do you need a phone, or because I guess that you need at least a bit of compute power.
Yeah, that's a great question to ask. I try to touch it, but it proves that this is the first question which people always have, that the full 3D needs to have way more data and way more computation, or that's the assumption. But in reality, it's not true, because the bottleneck in the whole visualization pipeline is the eye. And the eye doesn't need more data points from light field than from a flat image, or not much more. I will explain. So to answer the question directly, for the content generation, like all the shading and reflections, we just use whatever other headset needs. It's just one image from one perspective, and we also ask for a depth map. This is generated by default, so no more computation. What we do on top of it is a synthesis of the perspectives which were not in that image. So we need to shift closer and farther objects a little bit for every subframe. But this is already happening only with like low color images, because we distribute the color between the viewpoints and then do the small shifts. And this on the proper hardware implementation doesn't take more than 5% overhead. So there is no more load needed for light field ultimately compared to just flat image.
Okay, nice. And I will steal the question from my colleague Stefan because I know him well. It's and I think it's a great question too. But since you have like kind of a prism to make the relay between the light engine and your holographic display or stack, your field of view is limited by the optimization of that prism, I guess. So what's the best field of view you can do without using a classical architecture of waveguide combiner?
So yeah, first you are right that if we just use very direct projection without any tricks, we have to go through a prism like this. It can be a bit smaller, it's about quality. So it's difficult to make this smaller. And currently we have 42 pixels, 42 degrees.
Okay.
We can do more or less, but then we of course change also the iBox by that.
Okay.
But there is a trick to walk around it. You don't have to project all frames to the same field of view. We have demonstration of that you can tile the images next to each other. So you increase field of view without reducing the iBox.
Okay, cool.
At the same time, it's kind of optimal projection because for the periphery, you really don't need colors or very little, you know. So you can get less data where eyes actually don't really see it and more to the center.
Tomas, I have a question for you. Tomas. Which company is bigger? ASML? You know ASML, right? ASML or Jabil? Which company is bigger? Jabil is 7 times bigger than ASML. Jabil is a giant, and Jabil is a corporate member of Optica. Thank you very much, Jabil, for your great support, and thank you very much, Hendrik, for being with us today. Tell us what we can do for you and what we can do for us. The floor and the attention of everyone is yours.
Hi, Jose. Thank you very much for the introduction. Let me just
7 times bigger. You have more than 250,000 employees.
Yeah, it's cool, isn't it? And nobody
More
knows this.
people than my city, Almeria. Almeria has 200,000. You have 250,000 employees.
Look, we have a meeting on AR, VR, and on the metaverse, just as you said, Jose. Thanks for the nice intro. Jose, you talked about the deal between Jabil and Intel. And also, I cannot speak about details. So this is the official news line that we bought some of Intel's photonics based product lines. Some for the future of AI, some for the future of large computation centers. Let's see where this goes in the future. Today is more about AR, VR and what we can do for the industry and what the industry can do for us. And I decided to go back a few years and show the story again from Magic Leap, which just a second. Sorry. Magic Leap, as we know, is an innovative startup. It's not a startup anymore, based on Plantation in the US, developing AR classes. And back in 2018, both companies went together. And what we did is we partnered and we provided prototyping manufacturing support and also provided equipment support. So partnering means we completed Magic Leap's internal production and manufacturing capabilities to provide capabilities for mass production at the end, manufacturing the whole HMD. In the prototyping field, we did the prototypes in Jena in Germany, center of Germany, and then transferred to our mass production site in Mexico. So this is what Jabil usually does, developing hardware someplace in the world and then transferring to the few mass production sites. And in terms of equipment, we also were able not only to adapt existing machines, but also to design some new machines for active alignment and for testing. And the experience that we brought into play here, that I would like to just list this, goes over all fields of optical and optomechanical development. So we do not develop components on our own, like LEDs or waveguides or displays. We use what the industry can provide to us, but we do all the illumination design based on those components, projection path, of course. We can design waveguides. We don't produce them on our own. For laser illumination, everything which has to do with despickling, we can cover. And then the whole range from finite elemental analysis, thermal design, implementation, and everything until the design of alignment and test systems. And this is what we do for the industry and what we also could do for companies like CREAL. Thomas, you asked for a manufacturing partner. Here we are. Let's get in touch. Let me go one step further into technology for microdisplays, just to show which assembly technologies are covered within Jabil. So this is all technology that we have in-house, either at our site in Jabil in Belgium. This is the left-hand side for the PCBAs. And all the rest is available in Jena, in Germany. So on PCBAs, everything until precision assembly. Then on wafer assembly, on wafer scale, we can do a chip on board, we can wire bonding, precision alignment, and with some effort also do flip chip in Jena. With automated assembly, automated test lines, and especially in the active alignment, we have machines and the capability to develop new machines for closed loop active alignment with precision feedback systems and up to 6-axis technology, which is really an advantage if you go from design to the really manufacturing line here. Just a few words about our site in Jena. The only thing I wanted to show you on the left-hand side are the clean room spaces. So we really have all the equipment in-house. We even have office space for customers in-house. So you can come and decide to stay for 2 months, 3 months, half a year, to be present on site during the sample builds that we are doing together. So everything is possible. And it's really in the center of Germany. And we can reach out then after those prototype builds to the global manufacturing lines of Jabil. So that's what I wanted to say. Thank you very much. And
thank you very much, Hendrik, for being with us and for the amazing support that you're giving to Optica as a corporate member of Optica. We have really made a lot of introductions to many of your colleagues from the silicon photonics part, which I've been told I'm not allowed to ask. That's okay. I hasn't been told that. So what is that going? How did it happen and who introduced? No, I'm kidding. First of all, I would like to ask you the Optica question. What can you do for the others? What can they do for you?
Well, so what we do for the others is we provide mass production support. We can do early stage manufacturing, sample builds from 10 to 100 to 1,000 pieces, and then up to millions per year. And Jabil has a massive power of supply chain over the whole world, with the ability to source in Asia, to source in Latin America, to source in Northern America, and combine this all. And besides the design stuff that I already talked about. And your second question was, what can the industry do for us? Well, we are interested in novel approaches, technology, but also manufacturing details to simplify AR and VR devices without sacrificing performance. So this would be cool.
I would like to bring back to the floor Ralph from Innoftech. He asked a question in the Q&A chat, but I wanted to wait until it was Jabil's presentation to see how the whole room will react. Ralph, could you read the question? Could you tell us your question now?
Yeah, this is just in case that we have guests here who do not know what Inoptic does, and we can actually keep the contrast of an AR display always constant, no matter where you are looking at. So even in extreme cases, if you look directly into the sun, we can ensure constant contrast. We do this with an eye tracker and a camera. So if the camera sees the sun and the eye tracker vector becomes collinear, then we dim one big pixel like this, and it's a time domain multiplexing system. So the question is basically, is there any demand? What is your opinion? When you go outdoors, it's a bright day, 100,000 lux, is it all working? And if not, we are willing to cooperate.
Hendrik, do you want to address that? I can tell you one thing. I come from the south of Spain. My city is Almeria, beautiful city for holidays, by the way. And there is really, the amount of lumens outside is huge. So whenever you are going from a tunnel and then you get out, the change in lighting makes you blind for a few seconds. So for us, this technology beyond AR, VR is extremely interesting. But in the AR, VR domain, what do you think of glasses that can keep the contrast and the luminosity constant? Hendrik.
I think this would be nice. Also, I think it's not, to my opinion, my personal opinion, it's not the key parameter for getting those devices into the field. Because from my understanding, the amount of applications dealing in such high background illumination environment is not the majority. So to my understanding, most of the applications will deal in more dim in-room environment where especially this requirement is not the biggest key. But anyway, for those applications which need it, I think the Inoptic solution might be a very good choice.
Hanan, what do you think?
I have the question, Ralph. You spoke about curvature. You spoke about is it needed to be, the surface needed to be flat, or is it possible from your side to integrate something with a curved surface?
This is a curvature. This is a curvature 6 glass.
Curvature 6.
Excellent. Yeah, and the flat LCD is sitting inside. So we have basically tilted the LCD by 15 degrees. Since the head is round, obviously. So we tilted the LCD, put it all in. We can also do
implant inside, the LCD is implanted inside in between.
Yes, it's sitting in here. And it's not only to be outside. If you have a bright window and you read content indoors and you come along with your eye, the bright window, then you cannot see the content. So what we do is we dim the moment your pupil reaches the bright window, and then we come darker again. It's a very smooth process. So what we do is we have one vector from a camera and one vector from the eye. And let's say the camera is the vector to the sun or to the bright window, whatever is disturbing you. And the eye vector goes slowly collinear with the sun. Then we dim it away. And our solution is better than pixelation. You might have heard about pixelation. It takes too much computation power. So we can save at least a third of the battery lifetime because we have only one big pixel, if you like. That is one advantage. And the second advantage is if you have alignment problems, if you do this, pixelation won't work, but our solution will work. So we have a very robust and yet sophisticated technology which we can offer, and everybody is invited to cooperate with us.
This is very
more photonics. Tell us,
Yeah, what's the added power consumption requirement by basically incorporating such contrast enhancing option? Because yes, of course, ambient light readability or sunlight readability is absolutely key, no doubt. We work on anti-glare solutions here at Morphotonics just for that, for mobile devices. But just given the fact that these devices with augmented reality glasses, you get a lot of power requirements on them on the battery drain. What additional power requirements are there for incorporating your technology?
Oh, you would be surprised. It doesn't take much power because it's a standard LCD element. It's like a capacitor. It doesn't take much power. You switch it on and off. And what we do is basically time domain multiplexing. We provide an open time slot, then we close it again, open again, and so on. So it's a pulse width modulation. And in this open time slot, you can multiplex either a distal display, like a windscreen display, or you have it just as an add-on to a proximal AR display. So both is possible. And again, with regards to your question, the power consumption is not high at all. On the contrary, it's less than any AR glass, I guess.
And the last question comes from Pia from Dispelix.
Yes, I love having all these additional technologies, but my question is, if I understood correctly, you also have cameras. Does this system add a lot of extra weight?
Right now we have photosensors, so-called true eye photosensors from Osram, 3 per eye. That works already quite good. And the ideal version, which comes out next year, has indeed a little tiny camera. It's a very small camera. We just need to identify the bright spots in the environment, like where's the sun, where's the bright window, easy task. And then we have 2 vectors. We calculate this in Hilbert space. It's a very easy calculation for the processor. And again, when they become collinear, we automatically dim and make it brighter when you are in a darker space. So it works quite nicely, actually.
Look at the clock. We started on time and we finished on time. I would like to first of all thank all the corporate members of Optica. Really, if you like what we are doing here, what Olga is trying to do, what Helena is trying to do, what Puya is trying to do, what Carmen, what Ali, what I'm trying to do here, only way to support us is to become corporate member of Optica. We provide you with market reports, we provide you with many membership benefits, discount, but the most important membership benefit is because we want to continue doing what we do the most, and it's bringing the two of you together. Thank you very much, everyone. Stay tuned. We have really great meetings coming. And also, if you are in Lausanne in a couple of weeks, for Quantum Industry Summit at Lion Tech with a huge agenda of executives. Until the next time, it was a pleasure. Bye-bye.